Okay, so lesson 2.8, it's a little bit of graphing. It's based on graphing. We've already done this chapter, though. Okay, we're graphing inequalities. So what's the difference between graphing inequality versus a line? Yeah, they're shading. You still have to graph the line, but then you have to decide where do we shade. Do we shade above? Do we shade below? And then we'll also have to talk about what type of line to draw. Do you remember anything about that? You could draw a solid line.
Or a dotted line.
Or a dotted line. Or dashed line, depending on what your teacher calls it. Okay, so a little bit I'm throwing at you. So if you would, get with me in the notes. And let's look at this first example. So what is the graph of y greater than 3x minus 1? So first of all, first thing I'm going to say, forget the greater than for a moment. How do we graph y equals 3x minus 1? And don't tell me you haven't done this.
You get the y-intercept of -1.
Okay. Y-intercept of -1? Because what form is this?
Slope-intercept of 1.
Yeah, y equals mx plus b. I taught this to you this year. Let me rephrase that. I reviewed it with you this year, right? You've seen this on a quiz already. So we have a y-intercept of -1. And what else do we have?
You have a slope of 3 over 1.
A slope of 3. And 3 as a fraction is? 3 over 1. That sounds a little familiar, doesn't it? Let me zoom in so you can see. So let's start here. Let's graph. We're going to put a dot for the y-intercept of -1. Where is a y-intercept of -1?
Down 1.
On the y-axis, you go down 1. Sorry, I know, the graphs are kind of sketchy. You can make it happen. How do I do my slope from this point?
You go up 3 and to the right.
Rise 3, run 1. Does that sound familiar? So I'm going to go 1, 2, 3, over 1. 1, 2, 3, over 1. Over how many dots do I want to make?
The entire graph.
As many as you want, right? Make a couple, make a few. I can also reverse this and go
Down 3 to left.
down 3, left 1. I'm not saying you have to make as many dots as me. You can make more dots than me. It's whatever. Okay. 2 big questions to finish this off. And the first question is, what type of line do I use to connect these dots?
Solid?
Your options are a solid line or a dashed line.
I want to say solid line.
And why do you want to say solid line?
It's not a greater than or equal to.
Okay, reverse that thinking then.
And it's a dotted line.
Okay. So because this is just greater than, what's missing? It's not equal to. Because there's no little line underneath this saying greater than or equal to, it's going to be a dotted or dashed line. Have you guys used the terminology dotted line before? What do you say? I say dashed usually, but it doesn't matter. Okay. So what I'm going to do is I'm going to connect these with a dotted or dashed line. Here's the deal. It's not a fully connected line, right? It's broken. So I used a dashed line, and I used the dashed line because it was greater than, but not equal to. If it had been equal to, I would have made it a solid line. The other question I have to ask myself, am I going to shade above or below? Don't use the word left, don't use the word right. Okay? Because this is y equals, we're looking in relation to y. And my y-axis runs up and down, yes? So because this is y equals, I'm going to look in relation to y, and it says y greater than the rest of this.
So it would be above.
So is y greater than numbers above or below?
Above.
Does it make sense if I say above?
Yes.
And that's because it's y greater than. I'm going to shade above. Now, where is above on this particular graph? I hate to use the word left, but yes, it happens to be on the left side. I'm not saying above is always on the left side though, right? It's just the way this graph is angled. My above is over here. Seriously? So we opted to shade above because it was greater than as opposed to less than. Okay. Questions on that? Is that coming back to you a little bit?
Yeah, I figured
Or if you're going to say, I've never seen this before, are you okay with it then? We're not going to argue with how much you have and haven't seen of this before. I promise it's not that bad, though.
All I know is I kept messing it up 2 years ago.
So, okay, now, I'm going to come off to the right here before we go to the next problem. I'm going to make a little chart here. Or just a little, I don't know if I want to show. How do we know when to use a dashed line versus a solid line? So what kind of symbols will have us using a dashed line?
Greater than or less than?
Greater than, which is what we just did, right?
Yes.
Or
Less than.
less than. Those are the symbols that have you use a dashed line. So then what's going to have us use a solid line eventually?
Greater than or less than. Greater than or equal to and less than or equal to.
Okay. The ones that have the equal to's, right? Greater than or equal to, less than or equal to. Those are how you know what type of line to draw. If it's equal to, I like to think it's equal to, I see this little line here that tells me to draw a whole connected line. Just a regular line, as opposed to a dashed line. The other question we have to ask ourselves, how do I know where to shade? My general rule of thumb that you will hear me ask is, are we going to shade above or are we going to shade below? And shading above or below is always, as long as it's y equals, that's what it's in reference to. When does it make sense to shade above?
When y is greater than your actual equation.
When y is greater than. And we can, it could be greater than, it could be greater than or equal to. When are we going to shade below?
When it's less than or less than.
Less, when y is less than or less than or equal to. Okay? The skills are not that hard, it's just you can't make any mistakes, right? You're putting several little skills together. But none of these skills are that hugely difficult here. Now, before I go back to example 2, let me, think if I recall you see a question like this in Math Excel. So let me have you guys think about this. Is the ordered pair 2, 3 a solution of y greater than 3x minus 1? I don't have this in the notes, but I'm going to handwrite it in. We're going to talk about it. Is the ordered pair 2, 3 a solution of y greater than 3x minus 1? So now, y greater than 3x minus 1, that's what I just graphed, isn't it?
Yes.
So we've got a couple different ways we can talk about this. We want to know, is 2, 3 a solution? I'm hearing no's. I heard no. I saw a head shake. If we're going to say no, why not? Why not, Lorna?
I just plugged them in, and it's 3 is greater than 5, which is not right.
Okay. Lorna says, I just plugged them in. Because 2 is an x, 3 is a y. So you ask yourself, is 3 greater than 3 times 2 minus 1? 3 times 2 minus 1 is 6 minus 1. So, whoops. Is 3 greater than 5?
No.
And hopefully you can confidently say no. Did anyone else do this a different way? And I like that. It's very right. I'm very happy with it. But what's the other good way? Maya? Okay. Look at, where does 2, 3 fall on this graph?
On the opposite shaded side.
Right 2, up 3. It's very close, isn't it? It's very close. So that makes it very tedious. But it is in the non-shaded portion. That makes it not a solution. Where are my solutions on the graph? Anything that's shaded is a solution. Okay? It's not in the shaded area, so it's not a solution. Now, both ways are good, yes? It all depends. If you're given a graph, sure, use the graph. If you're not given a graph, though, do you have to graph it to answer this? No, we can just plug the values in. So I'm happy either way. Questions? Okay, let's see. Let's practice with B. I might skip C, and I have a couple other side examples I want to throw in, but let's practice with B here. What is the graph of y less than or equal to 3/4 x minus 1? I will say the first thing I'm always going to say,
Ignore the greater than.
think of this as y equals 3/4 x minus 1. So when I go to graph this, I'm not going to think less than, greater than right now. I'll save that for the end. How do I graph y equals 3/4 x minus 1? What do we have here?
You've got a y-intercept of -1.
Okay. Y-intercept of -1.
And you got a slope of 3/4.
And a slope of 3/4. This is even before algebra stuff. This is pre-algebra stuff. You could have seen this as far back as 7th, 8th grade, depending on when you took algebra and when you took pre-algebra. So, okay, y-intercept of -1 means what?
You go down from the 0, 0.
You go down 1 on the y-axis. What's a slope of 3/4 mean?
Up 3 to the right 4.
Rise 3, run 4. You can rise 3, run 4 again if you want to make your line a little more precise. We can also reverse it and go down 3,
to the left 4.
left 4. And again, I will make sure the graphs I provide you on a quiz or a test are a little bit better quality. Okay. What do I do next? What do I have to do, Kylie? Solid line. Why solid line?
It's greater than or equal to.
Yeah. We are specifically going to use a solid line. And when I say solid line, I just mean a regular, everyday line. Just a regular line. And we're doing that because it is equal to. Less than equal to, technically, but because it's equal to. Regular, everyday line, folks.
And then you got to shade the roof.
Okay. What, are you saying I'm not done? I don't get to just move on to the next problem?
No.
Not if you want full credit, right?
Now you got to shade below.
Because there was an inequality sign, we're either going to shade above or below. What is this inequality sign?
Less than or equal to, so it's below.
It's less than. So we're going to shade below. Do I need to ask where below is on this graph?
No.
It's pretty obvious this time because of the angle, isn't it? I do encourage you, shade that whole side of the graph, right? Don't just shade a tiny little section. That whole side of that line should be shaded. Basics okay? Tell me if they're not. Okay. I'm not going to do C because it's very similar to what we've just been doing. However, I got a couple of side example special cases that I want to throw at you. So I think I'm going to put these special cases over beside C somewhere. And the first special case I'm going to put is what if you are given y less than 3 and you're told to graph it. So I'm going to sketch in an x and y axis right here. You can use C if you want.
Okay.
I'm not using C. And I have one more graph I'm going to add in too. So, but y less than 3. I give you an x and y axis and I say, okay, graph this just like you did the other two.
Your y-intercept is 0 because there is no y-intercept.
Disagree.
You disagree?
I disagree with you.
I don't know.
Okay, he said his y-intercept is 0 because there is no y-intercept. And I said I disagree. Good try.
Is
There
3 or 1?
is a y-intercept.
There is a
It's
y-intercept.
just 0.
No?
Is
Still
it
disagree.
1?
No? What
Is
did
it
that tell you?
3?
No, it's just
Less than.
you can use the 3 on the x-axis and just make it
No.
It would be okay.
Hold that thought for a later example.
Less than 3.
Emma?
Is the y-intercept 3 and there's no slope?
I'm not going to use the word no slope,
There's a slope of
There-
something.
but the slope is 0. Okay, so, okay guys, so what we're thinking of, okay, no, this is good. This is a discussion I want to hear, guys. This is all good discussion. These are all good thoughts because you've got to remember this, right? Okay, so if we think of this as a line as y equals 3, there is a y-intercept of 3 because this is also could be written as y equals 0x plus 3. So if you're saying there's, quote, no slope because there's no visible slope, I agree with that. But what is my actual slope?
3.
0.
Oh, you said slope.
Yeah, I said slope. So, one way to graph this is you think, okay, it's 0x plus 3. That means I have a y-intercept of 3. So that means I'm going to go up. I should be doing that in a different color. I'm going to go up 3, right? And I'm going to put a dot for a slope of, or a y-intercept of 3. What's a slope of 0 look like? It's horizontal, right?
Yes.
Because it's like a rise of 0, a run of whatever you want to put. Okay? So we can rise 0.
Run the entire
I can run 1. I can rise 0 again, run 1. I end up with a horizontal line. Now, if you are not a fan of thinking about slope-intercept here, here's my other thought. You can make an XY chart. If you get confused on, is this a horizontal line or a vertical line? Make an XY chart. If my equation says y equals 3, what is y always going to be?
3.
Y is always going to be 3. Does it say anything about x values?
No.
No, so your x, pick whatever numbers make you happy. So if if my x are 0, 1, 2, y's are always 3, can you graph the points 0, 3, 1, 3, 2, 3?
Yes.
Yeah, that's the points I happen to already have there. Okay. What are the 2 questions you're doing to finish this off? Is it solid or dashed line, or solid or dotted line? What kind of line?
It's dashed.
It's dashed because?
It's greater than.
No, it's dashed because it's not,
Less than.
it's
not
less
equal
than, it's not equal to.
It's one of those.
Yeah, one of those. Okay, so it's dashed. And what else? Am I going to shade above or below?
Below.
And it's y less than, so we're going to shade below. special case in a way, right? But if I'm throwing this in, this means you might see something like this special case in homework, right?
Yes.
So anytime it's y equals, it is a horizontal line. It crosses the y-axis when y equals 3. If it's y equals 3, it crosses the y-axis when y equals 3. Okay, I told you I had one other special example, yes?
Yeah.
You can probably kind of guess what it's going to resemble.
It's going to be what Kylie said.
X greater than or equal to 2 is what I'm doing for this special example. So X and Y axis, so I can graph this. Now, again, don't think about the greater than or equal to for a moment. Just think about the fact, okay, this is X equals 2. Thoughts on this one?
You go right 2 on your x-axis.
If it says X equals 2, we have to cross the X-axis at 2. Kylie?
It's just a vertical.
It's a vertical line this time.
It's
This
a
is where I said hold
solid-
that thought earlier,
It's
didn't
a solid vertical line.
So, on this one, we cannot think slope and y-intercept because there is no y-intercept. I'm never going to cross the y-axis. There is no slope. A vertical line has no slope. So, I can't think slope and y-intercept when it's x equals a number. You can, I don't know, did anyone like my xy chart from the previous problem? If you liked my xy chart idea, x equals 2 means all of my x values are
2.
2. Y's aren't mentioned, so y can be
Wherever you pick.
anything. So if I say 2, 0, 2, 1, 2, 2. Okay. What type of line did you opt to draw?
A solid.
Because it is equal to, we're doing a solid line. And then my other question, do I shade above or below? Above.
Where is the phone?
Because it says greater than, the official ruling is above. Okay. This is the one type of question, the entire lesson. You get to change the wording from above and below. Can we do above or below here?
No.
Technically,
You
if
have
flip
an
it
exact vertical
sideways-
line.
If
You
you flip it
can't-
sideways,
Okay, you can't do above or below. So this is the one
Aha,
time
right.
you get to say left or right.
To the right.
And in this case,
To the right.
greater than, where does greater than make sense to be?
Right.
To the right. Are you guys okay with that?
No matter what, it's supposed to be above or below.
Okay. That is all old news, right?
Mm-hmm.
I technically have taught you nothing new today that you shouldn't have already seen along the way in some other algebra class.
I did though.
I have retaught a lot, but you've probably seen bits and pieces of this at some point. Now, example 2. What's changing up here?
Absolute values being added in.
Yeah, absolute value.
And
So, this is going back to what I taught Wednesday and Thursday? Yeah, Wednesday, Thursday. I don't know, I'm trying to remember what days. So Wednesday and Thursday, do you guys remember me teaching absolute value graphs? Yeah. The rules are still going to be the same here. It's still going to be, do we shade above or below? Is it a solid or dashed line? The difference is what we graph. We're no longer graphing lines. What's that absolute value graph look like?
A V.
A V. In fact, I'm struggling not to say it when I say absolute value graph because I always want to say it's an absolute value V. That's what I describe it as. So that's the difference. Now, my recommendation, always start by having your equation y equals. Just like on the previous examples. It was already y equals, but in order to graph it, we want it y equals. So how do I get y by itself here?
Add 1 to both sides.
It's y minus 1. We add 1. Now, be careful here. You cannot add that into absolute value.
No. That's not
It's going to stay outside. And so I'm going to rewrite this as y less than absolute value of x plus 2 plus 1. Okay. We're going to follow the same steps as last time. First of all, forget the less than greater than sign for a moment. When I graph this, we're going to think of this as y equals absolute value of x plus 2 plus 1. Okay, dig back in your section of your brain that houses all that information from last week that I taught. Okay, it's in there. Just dig. Where is this absolute value v going? I like it. Left 2, why is it going left 2? When it's in the absolute value, we're going to go left or right, opposite the sign. So a plus 2 is going to take me left 2. Okay? The number at the end of the graph is up or down the direction of the sign, so it's going to go up 1. It sounds familiar, right?
Mm-hmm.
Now, think with me. If my graph goes left 2 and up 1, where is that new vertex?
-2, 1.
If I just went left 2, up 1,
Vertex is -2 and 1.
basically this graph is going to have the vertex at -2, 1. Okay, so let's do that. I'm going to go from 0, 0. I'm going to go left 2, up 1.
And then you go up 1, right 1, or left 1, because your slope is 1, 1.
Okay, so to draw the sides of the V, they have a slope of 1, right? Because there's nothing there. So they just have a slope of 1. It'd be different if there's a number out there. So up 1 over 1, up 1 over 1, up 1 over 1 on both sides. So it makes a V. So up 1, over 1, up 1, over 1. I'm going to go to the other side. Up 1, I just go over 1 the other way. Up 1, over 1. Same type V you guys were doing last week. Okay. Same 2 questions. What type of line, or in this case, what type of V am I drawing?
Dashed.
Because it is just less than, this is a dashed V. Dotted, if you prefer. The key is don't make it connected, and make sure I can tell when you go to do this on paper for me. Make sure I can tell it's not connected. And then, am I going to shade
You're going to shade below.
above or below?
Below.
Why below?
It's a less than sign.
We're going to shade below because it's a less than sign. Now, on this particular V, where is below the V?
Everything right underneath the V. And up
Okay.
the side of the V.
Okay, how about outside of the V maybe? So it's everything below the V, which means the only section of that graph you're not shading is the stuff inside the V. And there's lots of coloring going on. Shading. Let me be official here. Okay, questions here. That wasn't horrible, was it? Technically, you could argue I just taught you something new. But really, we just put together old skills. Okay. Let's practice with the next one. What is the graph of y minus 4 greater than or equal to absolute value of x plus 2? Thoughts on what I need to do first?
You gotta get y by itself.
Yeah, get that y by itself. If it's y minus 4,
You add 4 to both sides, but keep the
Positive 4 outside of the absolute value bars.
we're going to add 4. Y greater than or equal to, it stays absolute value of x plus 2, and then the plus 4 is outside. We know the shape of this graph is going to be a V. Where's my V going?
You're going to go to the left 2, up 4.
Left 2, because it's a plus 2 inside the absolute value, so we're going to go left 2. The number at the end tells me up or down, so I'm going to go up 4.
It's gonna be a solid line.
So while I'm here, what type of vertex is that?
Negative 2, 4.
And I don't know that you necessarily have to write the vertex today, but I'm just trying to, get you guys still thinking of it. So, left 2, up 4. How do I draw the rest of this V?
You go up 1 to the right 1 and to the left 1, and then from those original points you go up 1 to the right 1.
Up 1 over 1. Up 1 over 1.
And then you draw a solid line because it's equal to.
So line is solid. We can agree to that? Okay. Are you guys all way ahead of me and bored?
Kind of. I'm already into the shading.
That's good, because that means you know what you're doing. If you're ahead of me, I like it in a way because you know what you're doing, right?
Yeah.
So we picked solid because it was equal to. So I see that little equal to bar to make it solid. And,
You shade inside the V. Because that would be above.
okay, so this one we're shading above. This V is right side up. So above the V is filling in the V.
That's fine.
It does. It does look like a triangle. Okay. On the back side, we are going to flip over to the back side. All I need to get done is the top 2 problems. We're not doing the bottom 2. Okay? Those are not something we're worrying about right now. So real quick, do you understand what we're doing on A and B?
You gotta figure
We're
out.
reversing, right?
You gotta figure out the equation.
Yeah, we're reversing. So I had you guys looking at the vertex for a reason. We're going to need to know some information here. So, I would like to know, what is my vertex?
3, negative 2.
Okay? That vertex is right 3, down 2, for 3, negative 2. That also tells me my graph does what? It moved
To the right 3 and down 2.
right 3 and down 2.
So that means in your absolute value bar, you're going to have negative 3, and then outside of it, you're going to have negative 2.
Yeah. And, okay, I don't know. Do you guys remember the form from last week? I don't know how much you use it or how much you don't use it necessarily. But officially, the form we talked about was y equals a absolute value of x minus h plus k, where h and k come from your vertex. Although, in all honesty, if you just think of it, okay, h is my left or right, k is my up or down, that works too. So we are going to need to fill that in. What about A? What are we going to have to talk about with A? What kind of slope is this? And I know it's hard to see, but what does it look like is happening? If you look very careful there, there's a slope that is just going
Up 1.
up 1,
To the right.
over 1. So a slope that's going up 1, over 1 is just
1.
1, and that is your A value. Okay? And then, okay, what do you notice about the type of line?
It's a dotted, so it's going to be greater than
Okay?
or less than, whatever.
It's a dotted line, and my shading is where?
Above, so it's
Above.
greater than. Y is greater than.
And I guess I should have started with shading is above, so that means my choices are greater than or equal to. Which one do I pick here?
Greater than.
Greater than, because my line is
Dotted.
dashed, dotted. Oops, I guess you can't see what I just wrote there up top, but is that coming together for you?
Yeah.
Okay, so Y. We said greater than because it's above and dashed. My A value, there was no slope other than 1, so you don't have to put an A value. Absolute value of X minus right 3, so X minus 3, plus K means we're going to go down to minus 2. So very similar to what you did last week in lesson 2.7, except you've got to throw in a less than or greater than sign now. Okay. I'm running out of time for B, but what is the one gigantic difference?
Well, it's flipped.
My V's upside down. What's that going to affect?
It's going to affect
The A? Because my slope, instead of going up 1, right 1, is going to go
down 1.
down 1. So since it goes down 1, right 1, I'm going to have a slope of
Negative 1.
-1 is what I want to mention there. And that is your A value. So I'll write the answer here in case you want to try this on your own. I know I don't have time to explain it, but I will write it there. Okay, it's Y greater than the negative. Notice I just put negative instead of -1. Absolute value of X plus 4 plus 3. Okay, lesson 2.8 homework. Do it. Some of you have some serious catch-up to do. Do some Math Excel homework tonight, okay? See me if you have questions. And I'm not doing the next 2 examples, so we're done with notes. So lesson 2.8 in Math Excel.